The common log is really just a special kind of logarithm. The common log is a log with a base of 10. Except when we have a log with a base of 10, we don't write log base 10. Instead, we use just log. Sometimes you might see it with a capitalized letter L. But this is the button on your calculator for log. So when we want to solve an equation like 10 to the x minus 2 is equal to 190, we get rid of the base by using a logarithm. Since we have a log of base 10, we would just use the common log. And that will get the base and the logarithm to cancel, so we'll be left with x minus 2. And we go over to our calculator to evaluate the log of 190, which is 2.278. Then we're going to finish up by adding 2 to both sides in order to get the minus 2 to cancel. So x will equal 4.278. Now, because we have that log button on our calculator, we can use the common logarithm to help us solve exponential equations where the base isn't that common number 10. For example, here where we have 5.1 to the x is equal to 304. Instead of getting rid of the 5.1, what we can do instead is to just take the common log of both sides. So the common log of 5.1 to the x would be equal to the common log of 304. Now we do have this power property for logarithms. Since x is the power, that can come down as a coefficient. And what we'll be left with is x times the common log of 5.1 is equal to the common log of 304. And it's at this point that we can go over to the calculator and evaluate those logarithms. The log of 5.1 is 0.707. So we'll have 0.707x. And the log of 304 is 2.482. Now we're just dealing with decimal numbers, and everything works as it always has. Since we're multiplying by 0.707, we'll divide by 0.707 to get those two to cancel. And what we'll be left with is that x is equal to 3.510. Now we can use that similar idea to calculate logs of any base on our graphing calculator. For instance, let's start with a log with some base of some number c. That has to have some value. I'll call it x. By the definition of logarithm, that means that b to the x power would have to equal c. And we can do the same thing that we were just doing, where we take the common log now of both sides. So the log of b to the x is equal to the log of c, common logs on both of them. Again, we have that same power property that takes the x and brings it out in front as a coefficient. So we'll have x times the common log of b is equal to the common log of c. Since that common log of b is just a decimal number, we can get rid of it on the left side using division by just dividing both sides by log of b. Then we have that x that we started with, that is the same as the common log of c divided by the common log of b. So in essence, we just took this log base b of c and turned it into the ratio of two common logs. I mean, we could go even one step further and say that if we started with the log base b of c, we can turn it into this fraction with log of c in the numerator and log of b in the denominator. But we just arbitrarily use the common log. We can go with any base that we want for these two logs as long as they're the same. Then that would be the change of base formula. So how does that come into play? Here we have log base 3 of 9. Now we know that the answer to this is going to be 2, right? Because 3 to the second power is 9. But we can evaluate this on our calculator so that when we start with the log base 3 of 9, we can use the change of base formula to turn this into a fraction. Now, how I usually visualize this is by drawing my fraction bar right here and going with the log underneath it. So we can rewrite this common log, this log base 3 of 9 as the ratio of two common logs. Log of 9 divided by the log of 3. Then just be careful as you type this into your calculator. If your calculator puts a parenthesis and you're going to do the log of 9 divided by the log of 3, you're going to want to make sure that you end the parentheses on each of them. So the log of 9 divided by the log of 3 is 2.